We're going to keep going on. Now the last one. It's the vertical bisector of this segment, segment ZX. It has to go through the midpoint. So I'm going to first find the slope of segment ZX, and that it's negative. I can see that. The rise, it starts at 7 but goes down to 1. So that's subtract 6. Then the run, it starts at 0 and then goes to positive 2. So that's a change in positive 2. So this is negative 3 would be my slope. So what's the slope of a perpendicular line? Positive 1/3. So I've got my perpendicular slope and I've got my midpoint because it's bisecting it. So we're going to go ahead and plug it into the point slope formula. And so I'm going to get that this is so we're going to add 4 to both sides. The whole number 4 is 12/3. So when I add 12/3 over here, it's going to give me a positive 11/3. Are we okay with this? Do we all agree? Do we see any mistakes or any questions? You got to hit me up. I can't read minds. Okay, from here, we got to figure out where are the coordinates of this circle center. So where does it intersect? We have to solve a systems of equation. Choose 2 of these equations. Choose 2 of these equations that seem to be the path of least resistance, and so that we're going to have to solve it. Since they're already in slope-intercept form, and they are solved for y, like y equals, y equals, y equals, the easiest method for here is going to be substitution. And so I'm going to set 2 of these equal to one another because they all equal y. The way I'm going to choose which 2 to set equal to one another is I see that all the fractions in this equation and all the fractions in this equation all have even denominators. So I'm not going to mess with the thirds. I'm just going to keep my fractions that have denominators that are even numbers. Alright, so this is me solving systems of equations now. I'm going to take this guy and set them equal to each other. So I've got a negative 1/2 x plus 3/4. Now this equals y, right? Equals y. Yeah. But instead of equaling y, this also equals y. So I'm going to set it equal to this expression, negative 7/4 x plus, this, minus 29/8. Okay. Setting them 2 equal to each other. So we do not have to deal with a bunch of different fractions. We can multiply both sides of the equation by the common denominator of these 4 fractions. First off, let's take this one step at a time. Am I allowed just to multiply both sides of the equation? By whatever I want? It has to be the same thing. What justifies me multiplying both sides of the equation by the same value? The multiplication property of equality. So we know that we can multiply both sides of this equation by whatever we want. As long as whatever we do to the left-hand side, we got to do to the right-hand side. So we can definitely do that. So, well, what number are we going to choose? Well, if we multiply by the common denominator, then all of these fractions will turn to whole numbers, or the coefficients will turn to whole numbers. So what's the common denominator of these 4 fractions? 8. So I'm going to multiply the left-hand side of this equation by a positive 8. I'm going to multiply the right-hand side of this equation by a positive 8. So when I take the product of 8 and negative 1/2 x, I know that my value is going to be negative, and I know that's going to have this variable x. So what's 1/2 of 8? 4. Next one. I'm going to multiply 8 to a positive 3/4. I know that it's going to be positive, because a positive times a positive. What's 3/4 of 8? 6. Remember, we can use our calculators for this as well. When you type a fraction into your calculator, what must you make sure you do? Put each fraction in its own set of parentheses. Please make sure you do that. Okay, so now let's go to the other side. We've got a positive 8 times a negative 7/4. I know this value is going to be negative. So what's 7/4 of 8? 14. Good job. Let's use your calculators, alright? Use your calculators. And then we've got this negative 29/8 times 8, where the 8's just cancel, so this is negative 29. Oop, I forgot my x, I'm at negative 14. So someone please check this for me. You're looking good? Alright. So now we've got an equation with 4 terms. 2 of them have variables, 2 of them are constants. Move all of your constants on one side, move all of your variables on the other, and this is just a simple algebraic equation. So I'm going to add 14x on both sides, and I'm going to get that this is 10x. I'm also going to subtract 6 from both sides. I'm also going to subtract 6 from both sides and get that 10x is equal to a negative 35. What's the last step I'm going to do? Divide by 10. And so my final answer for the x coordinates of this circumcenter is at negative 3.5. If you want to keep it as fractions, and that's what I like to do, this would be negative 7 halves. Negative 7 halves. But we're not done. We need to figure out what is the y coordinates. We're going to plug in x into one of these equations. It doesn't matter which one you choose, but you're going to have to plug x that equals negative 7 halves into here or there or there. You're going to have to plug it in somewhere and figure out what y is. So, which one do y'all want to choose? Green, blue, or red? Green. Okay. Sounds good to me. So I'm going to go ahead and erase this work, because we already know what x is. You would not erase it on a test. You need to leave all of your work, but I'm running out of board space. So, here we go. I'm going to take y equals negative 1/2 times x, but I know that x is a negative 7 halves, and then we're going to add 3/4 to that. Well, this is going to work out nicely, because when we take the product of these two fractions here, I'm going to get a positive 7/4. I get a positive 7/4, and so now these two fractions have common denominators. I can add them right up and get that y is equal to 10/4, but that reduces down to positive 5 halves, and the decimal representation for 5 halves is 2.5. So, C for circumcenter, my x value is a negative 3.5, and my y value is a positive 2.5. If you want to keep it as fractions, then that's what it would look like.